you can see simple linear regression model of which you had the y is equal to beta naught plus beta 1 x1 plus epsilon I, but this epsilon I is the error term, which is normally distributed in mean zero variance sigma squared. Then this is the independent variable. Then this is the slope. Then this is the intercept. Then this is the dependent variable. And we are insisting that for simple linear regression, this dependent variable must be continuous. Is that okay?
Yes.
Then we say that we can still extend this to a case where
We can't hear you.
You have more than one independent. And let me just move this one here. So that, can you hear me now?
Yes, right now I can hear you.
That's why we need the person who says he can't hear or hear. Okay, so the second case we are dealing with have more than one. So guys, always the simplest case is a simple linear regression. And for you to do a simple linear regression, it means you need two variables. One, the dependent variable, and it must be continuous, not optional, must be continuous. We don't care what the independent variable is, whether it is continuous or categorical, we don't. Is that okay?
Yes.
Then we say that there's an extension where we have now more than one independent variables. Our focus is on the independent variables when you're talking about multiple linear regression. So it means you still have your y, which has all the properties of the
excuse me, Prof.
Beta naught plus beta 1 more than 1, so plus error. Yeah, can you hear me?
Yes, I can hear you, but you're breaking.
Can we try maybe for the next few minutes? If I'm still breaking, then it means I have to change my location.
Kindly change, because you've been breaking for quite some time.
Okay, but this place, it's showing that I'm on LTE. How about now?
Now you're clear.
So we try for a few minutes, we see if I'm still breaking. So if you hear me breaking, just alert me so that I see the frequency. Then I see you, then I'll have to move.
Okay, I will let you know.
Okay. So we have more than one, for multiple linear regression, we have more than one independent variables. So these are the independent variables. The other properties remain as what we had for the simple linear regression. Is that okay?
Yes.
Now, this is what you did in statistical methods 1, where the focus is that the y will always be continuous. Now, we discussed last week some of these assumptions of the simple linear regression model, multiple linear regression model, and we saw that some cases, the y is not continuous. And when is the y not continuous? For example, when y is binary, like for example, 1, 0, or dead or alive, or malaria positive, malaria negative, or cases where you're talking about counts of people who experience something, then in that case, it's not continuous. If it is a count, if it's a categorical, it's not continuous. Is that okay?
Yeah.
And we say that in that case, that's when we go to generalized linear models. And I also remember saying last week that simple linear regression and multiple linear regression together, they belong to the general linear model. General linear model. General linear model does not have acronym. Then you said when your Y is not continuous, then you go now to generalized linear models. Is that okay?
Yes.
An example of generalized linear model is a case where you have, let's say, assuming, let's say you have, get an example. For example, if it's a household, the food security situation of the household. 1, if the household is food secure, 0 if the household is not food secure. Is that okay?
Yes.
Is that okay? So
yes.
you'll be having data like that. Is that okay? For example, here we have gender of the household, head, and location. Place of residence. Let's say urban, rural, something like that. Is that okay? So gender,
Yes.
then we have, let's say another thing is age. For example, gender here is 1, 2, 2, 1, 1, 2, 2, 1. Place of residence, you have urban, rural, 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 urban, sorry, urban, urban, urban. Then age, you have 21, 36, 48 years, 38.3 years, 49 years, 62 years, 80 years, 72 years. Is that okay?
Yes.
So here now, if you want to check whether gender, place of residence, and age have an effect on the food security, the food security is captured as a binary, so it's not continuous. So we cannot do multiple linear regression. Is that okay?
Yes.
So here we do logistic regression. Logistic regression. When the dependent variable is binary. So once your dependent variable is binary, then you use logistic regression. Is that okay?
Yes.
And are you doing probability distributions or you did before?
We are doing it right now.
Have you started the unit?
Yeah, we started it yesterday. Yesterday was our first class.
Did you cover any probability distribution?
Not yet. We just did
What did
an
you cover?
introduction. We just did an introduction.
What did the introduction entail?
We just defined some, we just did some definitions.
Okay.
Not,
now, guys, remember, probability is just a chance of something occurring. Is that okay?
Yes.
Probability is a chance of something occurring. Later on, we'll discuss something related to probability, which is the odds. I know a good number of you are good bettors. I know Betika, Bet Niger, you guys are good in that. So another thing that usually comes up when you are betting is the odds. Odds is not probability. It's related to probability, but it's not probability. So we'll cover that. For now, let me just speak about probability. Is that okay?
Yes.
So probability is the chance of something occurring. Is that okay?
Yes.
And there are certain things in life that we know their probability of occurrence follows certain functions. Is that okay?
Yes.
So if you can model if you can quantify in terms of a function the probability of something occurring, and you write an equation for it, that equation is what we'll call a probability distribution. Is that okay?
Okay.
One of the simplest probability distributions is what we call Bernoulli distribution. Bernoulli. Bernoulli distribution. Is that okay?
Yes.
Bernoulli distribution is used to model experiments where, or rather, let me say, not use experiments. It is used to model outcomes where only two outcomes where there are only two possibilities. It is used to model outcomes where there are only two possibilities. Is that okay?
Yes.
So anything in life that has only two possibilities, when you ask yourself, what is the answer for this? There are only two possibilities. Can either be this or that. Those ones will always be modeled using something we call Bernoulli distribution. Is that okay?
Yes.
And the Bernoulli distribution for example, if you want to say that y follows Bernoulli distribution, we write like this: y follows like that, then Bernoulli. Is that okay? Like that.
Yes.
Then the Bernoulli distribution has only one parameter. All probability distributions are usually governed or have a structure where there are some parameters, some unknown things. Is that okay?
Yes.
So Bernoulli distribution has one parameter only, which is the P, which is the probability of success. Is that okay?
Yes.
Probability of success. Is that okay?
Yes.
So this is the short form for it. Is that okay? For the Bernoulli distribution.
Yes.
The long form is that P of y, if you want to write it in long form, it is written as P of y is equal to P raised power y into bracket 1 minus P raised power 1 minus y. Is that okay?
Yes.
Remember, y is the probability of success. Success, one of the outcomes. Remember, we said that there are only two outcomes in a Bernoulli. So you usually define one of them as a success. Is that okay?
Yes.
So P now will correspond to the probability of having that outcome that you've defined to be a success. Is that okay?
Yes.
So this is how the Bernoulli distribution looks like. The Bernoulli distribution. Is that okay?
Yes.
I repeat again. The Bernoulli distribution, you only use it in a case where your variable or the thing that you are interested in has only two outcomes. Is that okay?
Yes.
New whiteboard. So I'm still continuing with the Bernoulli. For us to understand logistic regression, we need to understand this Bernoulli thing. Guys, for you to do statistics or data science, you must know probability distributions in and out. So kindly, the unit that you are being taught by, I think I was told it was Professor Chichir, kindly take it seriously. It's one thing that you will not be told, and sometimes it can be boring. But if you don't understand it, you cannot do statistics, you cannot do data science. Why? Because most of the time we'll be required to simulate some data. Is that okay?
Yes.
And for you to simulate data, anything that is happening in the world has to be attached to a probability distribution for us to simulate data for it. Is that okay?
Yes.
So allow me to go back to Bernoulli distribution still. So in Bernoulli distribution, variable, a random variable is just any quantity, numerical quantity that holds a value from an experiment. Is that okay? Is that okay? Hello?
Hello, we've lost you for a while.
You guys were quiet. I wasn't hearing anything. So I'm saying any quantity that we measure it, but we don't record the data, let's say we just give it a name, we'll always be calling it a random variable. Is that okay?
Yes.
I know this is not syncing well, but let me just try. If we were doing it after maybe probability distributions had been done by Chirchir, I think it would be better. Up to now, you guys have not done any probability distributions.
We have. I think we did binomial. Which other one? Chi-square?
In which context did you do chi-square or did you do binomial?
I think we just did the introduction to chi-square and binomial.
Okay, let me try and do something. Is that okay?
Okay.
So a random variable is an outcome of an experiment. A random variable is an outcome of an experiment. It's usually numerical. It's usually, that is, it ends up being a value. Is that okay? And we denote random variables by capital letters, either X or Y.
Excuse me?
We
can't hear you.
Can you hear me now? Can you hear me now?
Yes, we can hear you. I think Stephen is the one with an issue on his end.
I also can't.
Really? I cannot also hear?
No, I'm quiet right now. I'm quiet right now. We're just trying to ascertain. So, were you guys hearing me and one person was not hearing, or was it? Because sometimes, you know, you can...
Okay.
Yeah.
I can't hear you.
I can't hear you.
No, sometimes it's okay, sometimes it's not. I don't know, it's your application.
Okay, give me some 2 minutes. I change location, then we see.
Okay.
Okay, just give me some 2 minutes. I'll mute.
Baby.
Recording stopped.
Can we try now?
Yes, now I can hear you.
Okay. Let me try
Recording
then
in
if
progress.
it's not. If it's not, then we see what to do. So I hope I'm audible now.
Yes, you are.
Okay, guys, as I was mentioning that, you know, you must understand the probability distributions for you to say that you are doing data science or statistics. If you don't understand them, guys, statistics or data science becomes very difficult. Is that okay?
Yeah.
So any quantity that we measure in real life usually follows some distribution. Is that okay?
Yes.
That quantity, when you are in the realm of distribution, we usually call it that quantity. Any quantity that you measure, we'll call it a random variable. Is that okay?
Yes.
So think of random variable just as any variable. Is that okay?
Yes.
But for random variables, we do not have the data values themselves, but we have a function that describes that data process. So think of it as a data process and not the data itself. Is that okay? It's a data generating process. Is that okay?
Yes.
So we usually denote random variables using capital letters, either capital X or capital Y or any other capital letter. Is that okay?
Yes.
Random variables can either be continuous or categorical. So any data generating mechanism that leads to a value, a random variable that allows for decimals, we'll call it a continuous one. If it doesn't allow for decimals, we call it discrete. Is that okay?
Yes.
So the way we have continuous variable and discrete variables, we also have continuous random variables and discrete random variables in a similar manner with the same meaning. You just look at it, can it admit a decimal point? Is that okay?
Yes.
Now, let us take an experiment. So let me approach it this way. A random variable y sorry, let me approach it in a different way. Let me just see and do this. If you do an experiment, is that okay?
Yes.
If you do an experiment and in that
Excuse me, sir. We can't hear you. You're still having
there
problems.
are only two possible outcomes. Other guys, can you hear me?
You are breaking a lot.
Oh.
Yeah, I don't know what to do anymore now. I was breaking a lot, or I was just breaking.
You started breaking after clearing the Y.
The problem is that now I don't have any other option of internet connection because I've just stopped somewhere along my way home because I was just coming from Westland, so I had to stop somewhere. I don't have any other option for internet. I only have Safaricom. Now we'll just have to try. So if I break, you let me know, then I repeat a point. Is that okay?
It's okay.
One second. My data shows it as LTE. I don't know why. Okay, let's try then. If it breaks, you let me know, then I repeat a point. Is that okay?
Okay.
Yeah. So if you do an experiment, and in that experiment, it has only two outcomes. Is that okay?
Yes.
On top of that, you only, sorry, and you do the experiment only once. Is that okay?
Yes.
For example, you are tossing a coin. That is an experiment. Is that okay?
Yes.
You are tossing a coin. When you toss a coin, what are the possibilities?
Head or tail. Two
Head or tail. And there are only two possibilities. Is that okay?
Yes.
Then when we say that you do the experiment once, we are saying that you toss the coin once. Is that okay?
Yes.
Is that okay?
Yes.
Another example. You meet somebody on the road. Is that okay?
Yes.
And any person you meet on the road, you do an experiment where you test the person's blood sugar. Then you declare the person either is diabetic or not diabetic. Is that okay?
Yes.
And you only do it for one person that you meet, the first person that you meet along the way, only one person. Then when you do that experiment, how many outcomes are possible?
Two.
Which are these outcomes?
Diabetic or not diabetic.
Diabetic or not diabetic. And we are only doing it once. We only meet one person on the road and that person we do, and we are done with the experiment. Is that okay?
Yes.
Now, in that case, the random variable X in a Bernoulli distribution, so such kind of scenarios where you have only two outcomes and you do them once, they're usually modeled using Bernoulli distribution. Is that okay?
Yes.
The random variable X in a Bernoulli distribution, the random variable X checks whether it was a success. Is that okay?
Yes.
So it only tells you whether it was a success or not. Is that okay?
Yes.
That's how.
Sawa.
So in this case, remember one of the two options you declared to be a success, whichever option out of the two options you declare one to be a success. Is that okay?
Yes.
So in this case, X is equal to, X is equal to, can take on two values, either a 1 or a 0. Is that okay?
Yes.
Where 1 is whatever you call success. Success could be diabetic or could be ahead, depending. You just take 1. Is that okay? Or
yes.
Success could be not having diabetes. Is that okay?
Yes.
So if you do the experiment, X can only take two values only, either a 1 or a 0. Is that okay?
Yes.
Then this random variable X can only be modeled using Bernoulli distribution. Is that okay?
Yes.
So the Bernoulli distribution, so we'll say that X follows Bernoulli, and Bernoulli has only one parameter, P, where P is the probability of success. Is that okay?
Yes.
So success here could be that the X takes a value 1. Success is X is equal to 1. That could be a success. Is that okay?
Yes.
Okay. And how does the function Bernoulli look like? How does it look like? So the Bernoulli, we are still continuing with Bernoulli. So probability of X will be equal to P raised to power X 1 minus P raised to power 1 minus X, where X is equal to 0, 1. This part where we define the possible values of X is what we call the support of the distribution. Is that okay?
Yes.
Where we declare what are the possible values of X is what we call the support of the distribution. So if I ask you what is the support of X for Bernoulli, you'll tell me that the support of X is just two values, either a 0 or a 1. Is that okay?
Yes.
So from this, what is the probability of X being equal to 1? So where you see X in the function, you replace with a 1. what is the probability of x being equal to 1?
P.
So it will be equal to what? It will be p raised to power 1 because we've said that x is 1. Is that okay?
Yes.
P raised to power 1 into bracket 1 minus p raised to power 1 minus 1. Is that okay? Because we are replacing x equal to 1. Then this will give us what? P. So where P, remember what I defined as P. P is the probability that x is equal to 1. So if you define your x, your 1 to be success, then probability of x equal to 1, which is the probability of success, is actually equal to P. So P stands for probability of success. Is that okay?
Yes.
Is that okay?
Yes.
Guys, remember our random variable is x. Is that okay?
Yes.
In this function, what else do we have that is not x and is not a value, a known value? In the function that I've circled, sorry, I've drawn a rectangle around it. Let me draw it with the blue. In this function, is there anything that is not x and is not a numeric value? As in, you don't see 1, 10, 15, 10. It's not a numeric value and it is not x. It's a question, guys.
Yes, P.
It's a P. So any other thing that is there? Nothing. It's only a P. A P. If you know P, you know 1 minus P, right?
Yes.
If you know P, you know 1 minus P. So, I mean, 1 minus P is the same thing. So it's only P which is not known. Is that okay? So that is that thing that is not x and also it's not a value is what we call a parameter. Is that okay?
Yes.
So how many parameters are inside Bernoulli distribution?
1.
Only 1. And what is the name of that parameter? It's P.
P.
And it represents probability of success. Is that okay?
Yes.
For example, you sit for an exam. Is that okay?
Yes.
And your focus is only to know whether you've passed or failed that exam, and you only focus on one exam. Is that okay?
Yes.
How many outcomes are possible in an experiment where you do one exam? And remember, your interest is just to check whether you've passed or failed. Mm-hmm. So how many outcomes are possible when you do one exam?
2.
2 outcomes. Which are these outcomes?
Pass or fail.
Pass or fail.
Yes.
And we've already said here that how many exams are we considering for this first scenario?
One particular exam.
Only one exam. Because it is one exam, and each exam, when you do it, there are only 2 outcomes, pass or fail. Then when we model your probability of passing or failing an exam, then we use Bernoulli distribution. Is that okay?
Yes.
So for Bernoulli distribution, there must be an experiment. And in that experiment, there are only 2 outcomes. And you only do that experiment once. Is that okay?
Yes.
Is it clear?
Yes, it's clear.
Let us go to binomial. Binomial distribution. Is that okay?
Yes.
In binomial distribution, we do an experiment which has 2 outcomes, but we repeat the experiment n times. Is that okay?
Yes.
The random variable x counts the number of successes Is that okay?
Yes.
So what is the difference between binomial distribution and Bernoulli distribution in terms of the way these experiments are structured? Anybody?
The number of times the experiment is done.
It's only, the difference is only on the number of times the experiment is done. In Bernoulli, how many times is the experiment done?
Once.
Once. In binomial, how many times the experiment is done?
N number of times.
N number of times. In both of them, when you do the experiment once, how many outcomes are possible?
Oh.
2 outcomes in both of them. Is that okay?
Yes.
Is this clear, guys?
Yes, it is.
Now, remember, for Bernoulli distribution, the random variable X tells you whether it's a success or a failure. Is it a 1 or a 0? Is that okay?
Yes.
I've written it on my screen here. In a binomial distribution, what does the random variable X do? What does the random variable X do in a binomial distribution?
Count the number of successes.
It's written on the screen. It counts the number of successes. Remember, you've done those experiments. In the first experiment, there are 2 outcomes. One, you've already declared whether it's a success. You declare one of the options to be a success or a failure. Is that okay? Once
Yes.
you've declared what is success, then after you do it n times, you just count how many successes do I have in those number of times. Is that okay?
Yes.
For example, how many units are you doing this semester?
4.
4 units. Is that okay?
Yes.
And in each unit, assuming that we are interested in whether you pass or fail, is that okay?
Yes.
But now we look at the 4 units. So each unit you can pass, fail. Another unit, pass, fail, pass, fail. So you have 4. So you are repeating a Bernoulli experiment 4 times. Is that okay?
Yes.
Remember, in the case of passing and failing, what would you call success in your scenario? What would be success to you? A pass or a fail in the exam?
A pass.
A pass will be success. Naturally, a pass will be success. Is that okay?
Yes.
Now, I'm just asking the same thing many times. What does the random variable X do in a binomial distribution? It's on the screen, guys.
It counts the number of successes.
It counts the number of successes. So if you do 4 exams and your success is when you pass, is that okay?
Yes.
What are the possible values of X in that scenario when you do those 4 exams? What are the possible values of X? Remember, what does X do in a binomial? What does X do in binomial? It counts the number of successes. Is that okay?
Yes.
And remember, in each trial, we call them trials. In each exam, you can either succeed or fail. You can either succeed or fail. You can either succeed or fail. Is that okay?
Yes.
So X is counting the number of successes that you have. Let me ask, what is the largest value that you can have in the scenario that you have of you doing 4 exams?
4.
What is the largest value?
You can get 4 successes.
That is the largest value that you can have. Is that okay?
Yes.
What is the least that you can get?
0.
So it means X can take 0, 1, 2, 3, 4. Is that okay?
Yes.
Now, when we are modeling this, we've already said that this will follow binomial. So how do we write binomial? So binomial will say that X in short form, we usually write X follows, the tilde corresponds to follows. Binomial, let me just write it afresh. X follows binomial. And binomial has 2 parameters. The N, which tells you how many times the experiment is repeated. Is that okay?
Yes.
And the P, which tells you what is the probability of success at any time for each and every experiment. What is the probability of success? So binomial has two parameters, N and P. Is that okay?
Yes.
So how does it look like? So probability of X will be equal to NX
Okay.
P raised to power X 1 minus P raised to power N minus X. Remember, it means that you've passed X subjects. Is that okay?
Yes.
If the probability of passing any subject is P, if you've passed X subjects, then it means you've passed P. Sorry, the probability of passing and they're independent, you multiply the probability. So it will be P for the first subject times P for the second subject times P for the third subject times P for the fourth subject. So if you pass X subjects, then it means you've passed X number of times. Is that okay?
Yes.
So the probability will be P times P times P X time. What is P times P X times? What is P times P times P X times?
P power X.
It is P. You guys keep quiet. Then before you know it, then you don't hear me. So it is P raised power X. Is that okay?
Yes.
If P is the probability of passing, what will be the probability of failing?
1 minus P.
1 minus P. Is that okay?
Yes.
If you do N exams and you passed X of them, how many have you failed?
N minus X.
That's why the probability of failure, which is 1 minus P, is raised to N minus X times. Is that okay? The successes, the probability of success is raised to the number of successes. The probability of failure is raised to the number of failures. Is that okay?
Yes.
Now, remember, in a simple case, you have 4 exams. Exam 1, exam 2, exam 3, exam 4. Is that okay?
Yes.
For example, if you say that you passed 3 exams, is that okay?
Yes.
Passing these 3 exams could mean you've passed the first exam, second exam, third exam, but you failed the fourth one. Is that okay? You still passed 3 exams. Is that okay?
Yes.
It could be that you've passed the first one, failed the second one, passed the third one, passed the fourth one. Still, you've passed 3 exams. It could be that you've passed the first one, the second one, but failed the third one and passed the fourth one. Is that okay? Still, you've passed 3 exams. Is that okay?
Yes.
Or it could be that you failed the first one, you've passed the second, third, and fourth. So passing these 3 exams could happen in a different number of ways. Is that okay?
Yes.
To capture those number of ways in which you can pass the 3 exams, the combinations of passing those 3 exams, we use this thing we call combinations, which is this one here. So this is read as N combination X. So NX, this is just the same as this. Is the same as N combination X. Is that okay?
Yes.
So this part is used to take care of the different combinations of passing those X exams. Is that okay?
Yes.
Is that clear?
Yes, it is.
Now, let me ask you. I'm just repeating myself, guys, to be sincere. If you look inside this bracket, is that okay?
Yes.
Apart from X, which other thing is not a value? Which other thing is not a numerical value? 10, 15, 20, 25, 10, 0, 1. Which other thing is not a numerical value in that red box?
N and P.
N and P. Is that okay? So it means that
Yes.
for binomial distribution, it requires two parameters, the N and P parameters, for it to be specified. Is that okay?
Yes.
And what is the support of X? What are the possible values of X? Are they continuous or discrete? The values of X. Remember, what does X do in binomial? What does the random variable X do in binomial?
Count number of successes.
It counts number of successes. So in our case here, we are saying that we've done the exam, we've done n exams, and we are counting the number of successes. Will that be discrete or continuous? X, will it be discrete or continuous?
Discrete.
It will be discrete.
It will be discrete. There's no day we can say that we'll have 2.5 successes. We cannot have 3.8 successes. Is that okay?
Yes.
And if we do n exams, what are the possible values of X? What is the support of X? If we do n exams.
0 to n.
It is 0 to n. 0, 1, 2, up to n. Is that okay?
Yes.
Guys, any question on the difference between Bernoulli and binomial? And not the way I'm asking these questions. What does X do in a Bernoulli distribution? X tells you whether it's a success or a failure. Is that okay?
Yes.
In a binomial, what does the random variable X do? In a binomial, the random variable X counts the number of successes. Is that okay?
Yes.
Any questions so far? Let me go to another probability distribution called the Poisson distribution. The Poisson distribution, is that okay?
Yes.
In a Poisson distribution, this is the setup of the experiment. We are not doing yes or no things, or we don't do an experiment where there are two outcomes. That is not the setup. Is that okay?
Yes.
The setup of a Poisson is to count certain things. You define whatever you want to count and you count them. Is that okay?
Yes.
For example, you go to a road, a highway somewhere. Is that okay?
Yes.
And on that road, you count the number of Toyota, any vehicle that is a Toyota make. You count how many of them pass there between the period 6 a.m. to 6 p.m. So you go stand on the road between 6 a.m. and 6 p.m. Is that okay?
Yes.
And you count how many cars that pass there are Toyota model. Is that okay?
Yes.
So X will just be counted. So you must have a defined reference. Like in this case, I've said in this particular road between 6 a.m. and 6 p.m. Is that okay?
Yes.
So for a Poisson, X counts the number of occurrences or items in a specified section or period of time. Is that okay?
Yes.
Now, for example, if you go to the road there and start counting Toyota cars, remember we are not doing success and failure first, the way we do for Bernoulli. Is that okay?
Yes.
We just say we want to know Toyota. We just want to count how many Toyota cars pass in this reference period, which is between 6 a.m. and 6 p.m. Is that okay?
Yes.
What is the smallest possible value that I can record on any day?
0.
0. So it means that X will be equal to 0, comma. What is the next value that I can record after 0? Can I record a 0.2?
No.
What is the next value that I can record?
1.
1. The next value?
2.
2. Like that. Is that okay?
Yes.
What is the maximum that I can record on any day?
Infinity.
N.
N. What is N?
Unknown.
Unknown. N does not mean unknown. N. Remember, anytime you give a value, it's known. It's a parameter.
Yes.
You know, is that okay?
Yeah.
Do we know how many Toyotas I can count wherever I'm standing at today, between 6 a.m. to 6 p.m.? We don't know. So it will be dot. It will be dot open. It can go to any value. We cannot write infinity because maybe it does not get to infinity. So we don't know the maximum we can record in a day. Is that okay?
Yes.
So we say now X follows Poisson, and Poisson distribution has only one parameter, which is the lambda. Is that okay?
Yes.
And the lambda is the average number recorded. Is the average number recorded for whatever quantity that you are, for whatever thing that you are reporting on. Is that okay?
Yes.
So always remember, lambda is the average. What is the other name for average?
Mean.
Is the mean. Is that okay?
Yes. Excuse me, sir.
Distribution look like probability of X will be equal to E raised to a negative lambda. Lambda raised. Yes? Yes? Can you hear me?
Been break. Right now I can hear you, but you
from what time?
Breaking.
From what point?
After saying that lambda is the average.
Lambda is the average. Now we are just writing the general form of the Poisson, the structure of the Poisson. That's what I'm writing on the screen. Are you able to see it?
Yes.
Are you able to see it? So
yes.
It is given by E, where E is the natural number E. The natural number E is the value, it's 2.7 something, something, something. Is that okay?
Yes.
So it is that number 2.77 something, something raised to power that lambda, which is the average. Then lambda raised to power X over X factorial, where X is equal to 0, 1, 2, dot, dot, dot. This is the support. This is the support for Poisson. Is that okay?
Yes.
So if you look at this box, apart from X, how many things are unknown there?
Lambda.
It's only lambda. Why not E? Why are you not saying E?
E is none.
We say that E is a value, it's a mathematical value, very important value, which is equal to 2.7 something something. If you punch in E into your calculator, it will give you an answer of 2.7 something something. So it's not another letter, it is a known thing. Is that okay? Is that okay?
Yes.
So the only thing that is not known in this part or in this function is the lambda. That's why the Poisson distribution has only one parameter, which is the lambda. Is that okay?
Yes.
Any questions so far for these three distributions? Is that okay?
Yes.
Guys, you must know how the structure of these probability distributions. You must know these formulas. So as you'll be learning with the Chirchir, make sure you practice more on these formulas so that you know them. Is that okay?
Yes.
Just for example purposes. Example. Let me share my screen. Is that okay?
Yes.
Oh, sorry. Let me save these ones first, then I'll share my screen. Or anyone who can share his screen? Okay, no, let me share it myself. Let me just save this whiteboard. Let us just do some few examples on the probabilities. I'll stop sharing. Let me share. Let me get my something. Abigail, are you there?
Yes, I'm
Abigail, are
here.
you there?
Yes, yes.
I've shared something on WhatsApp. Are you able to put it on the chat box? Then somebody who is able to share on the screen can share. I want to send a couple of questions. Is that okay?
Okay.
Okay. So I've sent one. I'm sending two other.
Yeah.
I'm still sending a couple more.
Okay.
Still sending more. Okay, anyone who can share his or her screen with the pictures posted there? They're just images. I'm done. Anyone who can share his or her screen with those photos that Abigail has shared either on your group or on WhatsApp, on Zoom. Abigail, are you in a position to share your screen with those pictures?
Yes, I
We
can
want to
share.
look at one at a time, one at a time.
Yeah.
So let me stop sharing. Okay.
Let me download all of them.
Guys, by the end of this exercise, you should be able to know when to use binomial, when to use Bernoulli, when to use Poisson. All the questions that we're dealing with here are discrete, so only those three distributions will be at play. Is that okay?
Yes.
Then we also need to learn how to work them out. Is that okay?
Yeah.
Okay.
I'm sharing in a few. In a minute or so, yeah. Are you able to see my screen?
Yes, we can see your screen.
Okay, then this is the first one. I think. To drag this. Can I go ahead and read the question.
We are not seeing it.
You can't see it. Oh, sorry.
Yeah,
I
you
think
need to share. You need to stop sharing, then share.
Yeah, sorry.
You need to have it open somewhere, then share
let me
now
just
that
the
window.
entire screen.
Or the entire screen, that's the option,
Yeah.
But ensure your emails are closed and your WhatsApp. Otherwise, we'll not close our eyes to see what is on the screen.
Yeah. You can,
can we all see?
Yes.
Colleagues?
Yes.
So suppose you play a game that you can only either win or lose. The probability that you win any game is 55% and the probability that you lose is 45%. What is the probability that you win 15 times if you play the game 20 times? Is that okay?
Mm-hmm.
Now, for this question, will you model it using Bernoulli, binomial, or Poisson? So understand the structure of the experiment. Where are you moving?
Sorry, I think I moved. Sorry. Yeah, here.
When you're fiddling, it means you're not listening to what you're saying now. So which distribution should we use to model this one? Binomial, Bernoulli, or Poisson?
Binomial.
Binomial. Why binomial? Somebody said binomial. Why binomial?
Well, the probability of success is 0.55. And then
you can't get it if you approach it that way. Or if you get it, you'll miss it in a certain. So you have to approach it in a particular way. Why binomial?
We're only having two outcomes, and then we have the number of times.
We have two outcomes. The experiment, when you do the experiment, you have two outcomes, either win or lose. And the experiment has been done a number of times. How many times has it been done in total?
20.
20 times. So it's a binomial. Is that okay? Is that okay? Let me try if I can write on the screen. So remember the formula for binomial is the, let me try if I can write on the screen. Can you see my screen, what I've written?
Yes.
No.
Huh? I'm just writing in blue on top of the image.
I can see it. I don't know.
Yes.
Okay.
Yes, we
So
can
it
see
is probability of x, which is given by nx p raised to x. Oh, no. Let me just write afresh. Okay, what is our n?
20.
20, and what is our p?
0.55.
Because we are being asked for what is the probability you'll win 15 times. So because our interest is winning, then winning becomes our success. Is that okay? So probability of winning is 0.55. Is that okay? Then now we are looking for probability of x. We are being asked for probability of x. What is our x here in this case? 15. We are being asked to 15. Is that okay? So probability of x, so probability of x is equal to 15. That is what we are looking for. Is that okay?
Yes.
Now, Abigail, stop sharing so that I share, we do the calculation. Is that okay?
Yes, I've stopped sharing.
Yeah, let me see. Are you able to see my screen?
Yes.
Okay. So we are looking for probability of X, which is equal to, guys, notice that sometimes when I write, it makes additional marks. So just ignore. So it is given by nx, p of x, 1 minus p, n minus x. Is that okay? So p of 15, this will be equal to 20 combination 15, then 0.5 raised to power 15, 0.55, right?
Yes.
It's raised to power 15. Then what is 1 minus 0.55?
0.4.
0.45 raised to power n minus x. What is n minus x?
5.
5. So can you do this in your calculator and see? So to get this part in your calculator, you use the NCX part in your calculator. So you punch 20, then NC, then the NCX button, then you put 15, then you say equals and you get the value. Then you multiply with 0.55 raised to power 15 and 0.45 raised to power 5. What do you get?
Zero point 0.036.
0.036. Abigail, on the screen, it was showing the answers. Oh no, was it showing the answers? No, it doesn't have, right? Any other person who is getting the same?
Yes.
So you need to know how to use your calculator here. If you don't know, then you'll have a challenge, right? Abigail, the next question was asking for what? Probability of?
Yeah, let me just open it. Probability that you will lose all 20 games.
Just read it.
What is the probability? What is the probability that you lose all 20 games?
Probability of losing all 20 games. So you need to choose whether you want to solve it from losing or winning. Is that okay? So assuming that our success is winning, is that okay? Is that okay?
Yeah.
So what is losing 20? What is losing 20 games equivalent to in terms of winning? If you lose 20 games, then how many have you won?
0.
You've won 0. So in terms of losing, we are looking for probability of x is equal to 0. In terms of winning, is that okay?
Yes.
Guys, am I clear?
Yes.
This can be confusing.
Yes, you're clear.
The probability of x is equal to 0. So this will be equal to 20 combination 0. Then we maintain 0.55 because we changed it to probability of winning 0 games. Losing all the 20 is the same as winning 0 games. Is that okay?
Yes.
So 0.55 raised to power 0, then 0.45 raised to power what?
20.
What is n minus x? 20. So what is the answer? Guys, don't wait and try these things in the exam room. I know some of you will not do anything that we are doing on the screen. You'll wait for the exam for you to try these things. They'll surprise you. For me, once you are surprised, I just deliver the supplementary. I also get surprised and also deliver the supplementary. What do you get?
1.15.
Sorry. What do you get?
1.15 times 10 power minus 7.
It's that small.
Yes.
Yes.
1 times 10 raised power negative 7.
1.15 times 10 power negative 7.
Which is 0.000000000. Is that okay?
Yes.
Remember that probabilities will never be negative and they will never go beyond 1. So if I tell you to calculate a probability somewhere and you find it to be 2.5, then please just go pay for supplementary. Don't wait for you to be told. Is that okay?
Yes.
I don't need to do the other, so I think you get the gist. So I stop sharing my screen again. Abigail, you share the screen?
Yeah.
Okay, so we go to the next example. Allow me to read it. It's on the screen. Chris sells a charity magazine to raise money for homeless. Sorry, I repeat. Chris sells charity magazines to raise money for homeless by approaching people coming out of a train station. The probability that he will have a successful sale is 0.09. Is that okay? Determine the probability that if Chris approaches 40 people in random, he will sell the magazine to exactly 4 people. Is that okay? So this one, is it Bernoulli, binomial, or Poisson? Guys, did I lose you?
No, we're still here.
Is it
Binomial.
Bernoulli, binomial, or Poisson? Why binomial? Why binomial?
Because there are 2 possibilities, success in selling or failure in selling, and the experiment is done 40 times.
Correct. So anytime you approach a person, the person can either, you can either sell to the person or fail to sell the person. Then we have 40 people. Is that okay?
Yes.
So we are being asked for probability of X is equal to 4. Is that okay? So this will be equal to 40 combination 4. Then what is the probability of selling?
0.09.
0.09 raised to power what? 4?
4.
Then what is 1 minus 0.09?
0.01.
Huh? 0.01.
91.
0.91 raised to power n minus x. What is n minus x? 36. What do you get? Check if you can get the first item there. The answers are at the bottom there. Are you getting the answer at the bottom here? Hello?
Yes, we can hear you.
Yeah, I'm waiting for an answer.
We are working on it.
Yes. 0.2.
Are you getting that answer?
Yeah.
0.2011.
Yeah.
Is that okay?
Yes.
Other guys kindly confirm. If you've not invested in a scientific calculator up to now, then you'll find it rough.
Yes, it is 0.201.
Okay, if you are good with that, Abigail, take us to the next question.
Okay. Yeah. Can you see it? Question 11.
Yes, question 11. The probability of a random customer ordering a vegetarian meal in Ampala restaurant is 0.2. Then we go straight into the calculation. Find the mean and variance of the vegetarian meals in a total of 40 orders. Then determine the probability that in 50 orders, there will be exactly 11 vegetarian orders. Is that okay? This one, which distribution do we use? Bernoulli, Poisson, or binomial?
Binomial.
Again, binomial. Why binomial?
We have two possible outcomes.
There are two possibilities. What are the possibilities?
Ordering or not.
Ordering or not ordering. Then we've been given the probability of ordering, right?
Yes.
And we are being asked how many orders have been done.
A total of 40 orders.
So out of the total order, no, guys, I think we are making a mistake. What are the two outcomes? Read the question properly. The probability of a random customer ordering a vegetarian meal in Ampala restaurant is 0.2. Find the mean and variance of the vegetarian meals in Sorry, can you hear me?
You are breaking a little bit.
Can you hear me?
Yeah, now we can hear you.
Sorry, there was a call coming.
Okay.
Sorry,
Hello?
Can you hear me now?
Yes, we can.
Sorry, there's somebody making calls frantically, so most likely the person will make the call again. So, but anyway, we continue. Guys, we need to read it keenly. The probability of a random customer ordering a vegetarian meal in Ampala restaurant is 0.2. Find the mean and variance of the vegetarian meals in a total of 40 orders. So what is the issue? If it is binomial, which it is, what are the two options?
Ordering a vegetarian meal or not ordering a vegetarian meal?
So, not ordering.
Ordering a non-vegetarian.
A non-vegetarian meal. Remember, we are being told vegetarian and out of the total orders. So the two options, the order can either be vegetarian or non-vegetarian. Is that okay?
Yes.
What is the probability that the order is a vegetarian?
0.2.
0.2. Is that okay? Let us leave part A first. Let us deal with the part B. Part A, we've not done something there. I'll introduce it now before we move. Is that okay?
Yes.
Part B, exactly 11 vegetarian orders. Exactly 11 vegetarian orders. So we are being asked for probability of X is equal to 11. Is that okay?
Yes.
So probability of X is equal to 11. So this will be equal to N combination X, which is 40 combination 11. Then probability of ordering vegetarian 0.2.
Is it 40 or 50?
Probability of not ordering
0.8. Hello?
Yes.
Yeah, the probability of not ordering vegetarian is 0.8.
Correct, 0.8. So I put it there. So it will be 0.8 raised to what?
Power 39.
0.8 raised to power 39.
29.
29, because it is 40 minus 11. Is that okay? What do we get as the answer?
Excuse Prof. Are we working with 40 or 50?
Sorry, we are working with 50. Sorry. We are working with 50 because we are in the second part of the question out of the 50 orders. So this should be a 50. Thank you. 50, then we have what? 39. Oh, now I get where the 39 was coming. So what do we get?
0.1271.
0.127, which is the answer there, right?
Yes.
Guys, is that clear?
Yes.
Guys, let me handle something quickly here. For each probability distribution, maybe Abigail, stop sharing, but note the answer for this part A. For these two parts. Mark the answer down. I'll ask you the answer. So the expected value, another name for mean is expected value, and variance is usually denoted by variance of X. So note those two answers. 8 and 6.4. Is that okay? Guys.
Yes.
Yes.
So mean and variance for probability distributions. Once you are given a probability distribution, then there are known formulas for their mean and variances. Is that okay?
Yes.
So the first thing that you need to know, when dealing with random variables, another name for mean is expected value. So anytime you see expected value, what people are referring to is mean. Is that okay?
Yes.
Is that okay? Just
yes.
1 second. Let me send somebody a number here. Just 1 second. So the other name for mean is expected value. So anytime I ask you what is the expected value, I'm basically asking what the mean is. Is that okay?
Yes.
So if I want to say mean of X, this is the same as writing expected value, and the symbol for expected value is E. So E of X is read as expected value of X or mean of X. Is that okay?
Yes.
Variance of X, we usually just denote it as var X, like that. Is that okay?
Yes.
So each and every probability distribution, once you know the probability distribution, we can get the mean and variance of the random variable X for that probability. So if you are dealing with Bernoulli, with probability P, so if X follows Bernoulli probability P, we know that probability of X, this is given by P raised per X, 1 minus P raised per 1 minus X, right?
Yes.
So for this, then the mean of X is equal to P, and variance of X is equal to P into bracket 1 minus P. So once you know the P, then that is the mean of X. Is that okay?
Yes.
And the variance is just P times 1 minus P. So once you know the P, then you can calculate the mean and you can calculate the variance. Is that okay?
Yes.
Then about if X follows binomial with parameters N and P, is that okay? Binomial has 2 parameters. Is that okay?
Yes.
Then the mean of X, which is also the expected value of X, the mean of X is given by, you just take the N, you multiply by the corresponding P. Is that okay?
Yes.
And the variance of X will be given by, you take the N multiplied by P together with 1 minus P. You get the variance. Is that okay?
Yes.
The third one is Poisson. If X follows Poisson with parameter lambda, then the mean of X will be equal to lambda, and the variance of X is also equal to the same lambda. So for Poisson, both mean and variance are, you just pick the lambda. Is that okay?
Yes.
So if I give you a Bernoulli distribution, how do you get its mean? Where do you get its mean from?
Multiplying N and P.
Mean for Bernoulli.
No, for Bernoulli it's P.
For Bernoulli, it's P only. Then the variance for Bernoulli?
P multiplied by 1 minus P.
Correct. For binomial, what is the mean of X for a binomial?
NP.
And variance of X?
NP multiplied by 1 minus P.
So NP 1 minus P. For Poisson distribution with parameter lambda, what is the mean?
Lambda.
Lambda, what is the variance?
Lambda.
Correct. So Abigail, please share the screen again. The same question that we are dealing with, so that we deal with that first part. So after part 1, you ask, find the mean and variance of the vegetarian meals in a total of 40 orders. So there, we'd already say that this would be a binomial, right?
Yes.
In that case, for part A, what is our P and what is our N, given that it's a binomial?
P is 0.2 and N is
P is 0.2 and N is?
40.
40. So what is the expected value of X, or the mean of X?
It will be 0.2 multiplied by 40, which will give us.
And what do you get?
8.
8. Is that okay? Which is the answer answer that we have down there. This 8 here. Is that okay? What about the variance of x?
It will be 0.2 multiplied by 40 multiplied by 1 minus 0.2, which will give us that's 64.
64 or 6.4?
6.4, I mean. 0.4.
So for the three distributions that we focused on now, you must be knowing their mean and you must know their variances. Is that okay? Guys, this is important. This is important. We'll use them in the next class. Is that okay?
Yes.
Another example, Abigail, let us go first. During the winter months, in a certain village in Scotland, the probability of having severe fog is 0.06. Find the probability that in a given week, there will be no day with severe fog. There'll be no day with severe fog. Which distribution do we use here? Bernoulli, binomial, or Poisson? Bernoulli, binomial, or Poisson?
I think it will be binomial.
Binomial is correct. What are the two outcomes?
Having a fog or not having a fog in a day.
Having fog or not having a fog. Is that okay? In part A, what is our n there? What is our n?
7.
It's 7. Because remember, it is having a fog in a day or not having a fog in a day. And in a week, we have 7 days. So our n is equal to 7. Is that okay?
Yes.
Guys, is that okay?
Yes.
Yes.
So you can do it and check the answers are down there. Abigail, next example. Guys, if you are not following, please ask. Next example, so we have sheep are randomly scattered in a field which is divided into equal size squares. There are 3 sheep on average in each square. Is that okay?
Yes.
Determine the probability that on a given square there will be no more than 5 sheep. Which distribution do we use? Bernoulli, binomial, or Poisson?
Poisson.
Is what?
Poisson.
Why not Bernoulli? Why not binomial? Because the experiment is not about finding sheep or not finding sheep. We are just counting how many sheep we have. Is that okay?
Yes.
And the other thing that can help you know also, we've been given the average number of sheep in a square, which is our lambda. Is that okay? Another way of also figuring them out is just checking what parameters have you been given. If you look at this, we've only been given one parameter, which is the lambda rate. Is that okay?
Yes.
Guys, is this okay?
Yes.
Abigail, next, so you can do the exact calculation at your own free time. Next question. Water from a lake is tested and is found to contain an average of 3 bacteria per liter of water. A sample of 250 milliliter is collected from the lake. Determine the probability that the 250 ml water sample will contain exactly 2 bacteria. Which distribution?
Poisson.
Poisson. Is that okay? Because it's the number of bacteria. And already even in the question, we have the average. It has 3 bacteria per liter of water. Is that okay?
Yes.
But here you have to be careful, guys, when doing calculations related to Poisson. For Poisson, you have to change the mean or the rate or the lambda proportionately to what is being asked in the question. Is that okay?
Yes.
Like in this case, the average rate of 3 bacteria is in what quantity of water?
1 liter.
1 liter. But the question is now asking us for 250 milliliters of water. We are being asked questions in a 250 milliliters of water. So we need to get the rate or the average for this new size. Is that okay?
Yes.
So if the rate is 3 bacteria per liter of water, what is the rate in 250 ml? We need to rescale the rate to this new quantity. What will be the rate for 250 ml?
3 divided by 4.
It will be 3 divided by 4 because,
Yes.
because 3 liter is equal to, sorry, 3 bacteria is equal to 1 liter. Sorry, 1 liter is equal to 3. Therefore, 0.25 will be equal to, is that okay?
Yes.
Because how?
Yes.
What about now the second part? They're talking about a larger sample of 2 liters of water is collected. And now they ask you about the 2 liters. Here again, we need to rescale our rate. So what will be our average for the 2 liter sample?
6 bacteria.
It will be 6 bacteria per 2 liters. So now in our calculation, we don't use 3 bacteria. Now in the second part, we use, that is in part B, we use 6 bacteria per 2 liter. We use the lambda of 6. Is that okay?
Yes.
So for Poisson, be careful. For Poisson, be careful. The question might be, the rate might be given for a certain amount, but the question is asking you for a different amount. So you have to rescale the rate appropriately. Please remember that. Is that okay?
Yes.
Okay.
Excuse me, Prof. I have a question.
Yes.
Yeah, when we divide 3 by 4, we will have like 0.75. So is it okay to use it like that or?
Yes, it's okay to use it like that.
Okay.
I know it's the number of bacteria. It's the average number.
Okay.
It's the average number. Remember, average for bacteria, you can get 3 point something. In theory. So we use the decimals like that. Is that okay?
Yes.
Okay.
Okay. Abigail, another screen. Our website receives hits at a rate of 300 per hour. But a stated distribution that will be suitable to model the number of hits obtained during a 1 minute interval. Here, which distribution do we use?
Poisson.
Poisson.
We use Poisson because it's the number of hits. Is that okay? And remember, the question was giving us how many, what was the rate per hour?
300 per hour.
300. So what will be the rate for 1 minute interval?
5.
So you divide by 60, right?
Yes.
We have to change the scale. For Poisson, always remember, the trick can only be that the teacher can change the scale. So you have to be careful there to ensure that if the question is given in terms of hours, it asks in terms of hours. If they change to something else, you have to rescale first. Your lambda. Is that okay?
Yes.
For part D, what will be our lambda? when we are answering that part D, what will be our lambda? Part D, what will be our lambda? Hello?
Is it okay if we say 10?
Yes, it will be 10. Because the rate per hour, so 300 for 60 minutes. So 60 minutes is equal to 300. So what will be 2 minutes?
10.
Yeah. So 60 minutes is equal to 300. What about 2 minutes? So it will be 2 multiply, then you get your 10. Is that okay?
Yes.
Guys, do you get the hang of it?
Yes.
Okay, Abigail, you can stop sharing. Cover something quickly. I think by 8:30 we need to stop. So recall. For Banuli, then X will be, it has only one parameter P. Expected value of X is equal to P. Variance of X is equal to P into bracket 1 minus P, right?
Yes.
Number 2, for binomial, the initial is that X follows binomial. It has 2 parameters, N, P. Is that okay?
Yes.
Expected value of X will be given by, the mean of X will be given by
NP.
NP, and variance of X will be given by what?
NP 1 minus P.
Number 3, for Poisson, X follows Poisson with parameter lambda.
Lambda.
Then expected value of X is equal to what?
Lambda.
Lambda. Variance of X is equal to what?
Lambda.
Lambda again. Guys, there are two other regression models that are important that we need to know. One is logistic regression. So logistic regression is linked to Bernoulli distribution. Is that okay?
Yes.
Then another regression is the Poisson regression, which is linked to Poisson distribution. Is that okay?
Yes.
So once your random variable X takes on values, only 2 values, 1 or 0, yes or no, then it means it follows Bernoulli. Then the regression that you need to use for that case, if that is your dependent variable, then the regression to use is logistic regression. Is that okay?
Yes.
If your dependent variable Y is a count, how many, then we know that we use Poisson for counting, Poisson distribution, then the resulting regression will be Poisson regression. Is that okay?
Yes.
Now, so for these two, how does, I want to use the same screen. So logistic regression. How does the logistic regression looks like? So if your Y is equal to 1 or 0, is that okay? This is how you write the logistic. Is that okay?
Yes.
then it means that y follows Bernoulli with parameter p. Is that okay?
Yes.
Then the logistic regression now will be logit, then into bracket we put the mean. The mean is p. Is that okay?
Yes.
Is equal to beta naught plus beta 1 x1 plus beta 2 x2. Is that okay?
Yes.
Guys, have I put plus error?
No.
There is no error in logistic regression. You don't include error. Is that okay?
Yes.
Guys, this is what we call logistic regression. So logistic regression, what is on the right and on the left hand side is not y. It is the logit of p. I'll explain what logit is. Logit is just a function like log, square root, what. Is that okay? Is that okay?
Yes.
And I repeat, guys, this p here is the one that comes there. Is that okay?
Yes.
On the right-hand side, it just looks like the way multiple linear regression is, Cindy. But we don't put the error term. Is that okay?
Yes.
For the multiple linear regression, what do we usually have on the left-hand side?
Y.
Y. So here now for logistic, we don't have y, but we have logit of p, where p is the mean of y, is the expected value of y. Is that okay?
Yes.
So you use logit into bracket expected value of y. For Bernoulli, if y follows Bernoulli with parameter p, what is the expected value of y? I repeat, if y follows Bernoulli with parameter p, what is the expected value of y?
P.
It is p. So that p is the one that you put inside the logit function. Is that okay?
Yes.
Okay. For Poisson regression, allow me just to squeeze them here so that you can see them side by side. For Poisson regression, the y is equal to count. Is that okay? Count of whatever. Is that okay?
Yes.
Then y follows Poisson with parameter lambda. Is that okay?
Yes.
Then log, we don't use logit for Poisson, we use log. So log of lambda is equal to beta naught plus beta 1 x1 plus beta 2 x2. Is that okay?
Yes.
Do we have error term for Poisson?
No.
We don't have error term. Guys, if you write for me error term, I just give you a big X in the entire exam. If you just write an error term for Poisson or for logistic regression, I just give you a big X, irrespective of any other thing that you've written in that question. Is that okay?
Yes.
Again, if y follows Poisson with parameter lambda, what is the mean? What is the mean of y?
Lambda.
It is lambda, and that lambda is the one again we take and put it inside the log. Is that okay?
Yes.
For now, don't ask me where the log is coming from, where the logit is coming from. That's what we'll be doing in the next few classes. Is that okay?
Yes.
Guys, so when you're told to write logistic regression, first you start by writing the dependent variable and you show the two values. You show the two results. Is that okay?
Yes.
Then the next line, you must say that once you have the two outcomes, then that one has to be modeled using Bernoulli. So you have to say that y follows Bernoulli. Is that okay?
Yes.
Then the next thing is to write logit then of the mean, which is basically the P. So logit of the P is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, whatever. Is that okay?
Yes.
This thing that we are calling logit, you'll see later on, we'll give it a name called link. I want you to remember this. Link, a link function. Link function. Is that okay?
Yes.
So what is the link function for logistic regression?
Logit.
Logit. What is the link function for Poisson regression?
Log.
Log. I need you to remember those ones. You'll see where they are coming from, but for now, I just need you to cram them if you want to call it cramming. But in a couple of lectures, we'll be able to see what. So I'm just repeating my question. For logistic regression, what is the link function?
Logit.
Logit. What is for Poisson regression? What is the link function?
Log.
Well, after you write the link function, what do you put inside the bracket of the link function?
Average.
Parameter. Average.
You put parameter.
Average.
You put the average or the mean. Is that okay?
Yes.
So make sure you remember that one. So the link then into bracket, the mean then is equal to, then whatever is on the right-hand side is the same as what you usually have on the multiple linear regression, except for the error term. Is that okay? Is that okay?
Yes.
Okay. Consider the data below. So we had the food security. Remember the example that we started with? Gender, age, what did we have? Let me say income. Is that okay? So 10011101011. Gender is male, male, female, male, female. Guys, they might not be aligned, but when you're writing yours, make sure you align each and every row has a value. Is that okay?
Yes.
Female, male, male, female. Then age, let's say, is 20, 21, 23, 28, 48, 65, 21, 28, 32. Is that okay?
Yes.
Income per month, let's say, is 12,000, 18,000, 36,000, 20,000, 22,000, 25,000, 9,000, 68,000, 21,000. Is that okay?
Yes.
We want to fit a regression model because we have several variables and we want to check how they're related to the outcome variable, which is food security. Automatically, we have to fit a regression. Is that okay?
Yes.
So we want to fit a regression. Which regression should we use to check whether income, age, and gender influences the food security outcome? Income, age, and gender, if they influence food security outcome. Remember, so far we've discussed 4 regression models. We have the simple linear regression model, multiple linear regression model, logistic regression model, and Poisson regression model. Is that okay?
Yes.
So which model can we use to fit to assess whether income, age, and gender influence food security?
Logistic regression.
Logistic regression. Why logistic regression?
2 outcomes.
No, you've not. Come again. Repeat again. Repeat again.
Because we have 2 outcomes.
Male and female.
Oh,
So say something sensible now. They're
because,
saying because we have two outcomes, it's not sensible.
because food security has only two outcomes.
You must say what your dependent variable is first. First, anytime you are talking about regression models, first say what is your dependent variable in that scenario. Then continue to say other things. So can you try again?
So a dependent variable is food security and has two outcomes.
Correct. So we use logistic regression. Is that okay? I see, William, you said is discrete. If it is discrete, then we can use Poisson. Can we use Poisson regression? William. William. There's
Hello,
somebody called
yes.
William.
Yes.
We are saying the answer is logistics because it is discrete.
Somehow, because when you look at this, it's just like we have two outcomes, yes or no, which is kind of like categorical. But again, when you are looking at Poisson, you are looking at the counts. So that's why we don't use Poisson, but we come to logistic. Because these are
But
not
what
counts.
is your answer?
Pardon?
What is your answer? What answer did you give in the chat?
Logistic. But
why?
Okay, I said logistics because the outcome is either like it can be true or false.
No, I'm asking you what answer did you give in the chat box?
Okay,
for why logistic? For why logistic? I'm not asking you the logistic part. I'm asking when I asked why logistic, then you gave an answer.
Yeah.
Which you said was what?
Discrete.
Discrete.
Yeah.
Which is wrong.
Okay.
Do you understand why it's wrong?
Yes.
Why?
Because this one, because we have two options,
yes,
either discrete or
yes, it is discrete, but
yes.
there are many discrete types. Even counties are discrete.
Correct.
So if you say discrete has many things. It can be binary, it can be count, it can be something else. Is that okay?
Yes.
So discrete is not the crisp answer, because if you say discrete, then I tell you, why don't we use Poisson? Because Poisson also is for discrete.
I get it.
Yes. So this, for logistic, you have to be very particular. It has binary outcome. Binary means that it has two outcomes in the dependent variable. Is that okay?
Yes.
So if you are to write down the model, how do we write it? FS, food security is equal to 1 or 0. Is that okay? Maybe this 1 means food secure, and 0 means food insecure. Is that okay?
Yes.
Then we know that FS will follow Bernoulli. Once we see 0 and 1, we know it's Bernoulli. Is that okay?
Yes.
Is that okay?
Yes.
Then what is the link function for Bernoulli?
Logit.
Logit is equal to beta naught plus beta 1 gender plus beta 2 age plus beta 3 income. Is that okay? Yes. Guys, notice that I'm not using Y's and X's here. Notice that I'm not using Y and X's. You have to contextualize whatever you are doing based on the question at hand. Is that okay?
Yes.
Guys, any question? Any question? So another example, consider the data below. We have the cars that somebody owns. Is that okay?
Yes.
Then it depends on your age. Depends on your level of education. Let me just say education. And income. So you can be owning 0 cars, 1 car, 0 car, 3 cars, 4 cars, 0 cars, 2 cars. Is that okay?
Yes.
Age, let's say 30, 35, 21, 18, 36, 22, 44. Education, maybe this one has primary. This one has primary. This one has secondary. This one has, let's say, degree. This one has degree. This one has primary. This one has secondary. Is that okay? Income, 20,000 per month, 48,000, 56,000, 32,000, 41,000, 21,000, 18,000. Is that okay?
Yes.
If you want to check whether income, education level, and age influences the number of cars that somebody owns. You want to check whether income, education, and age influences the number of cars that somebody owns. Which regression model can we apply? Poisson. Why not multiple linear regression? Because we have many independent variables. We have many independent variables. Why not multiple linear regression model? Ndambuki.
Recording stopped.
Ndambuki.
Yes.
You said Poisson regression. Why not multiple linear regression? Yet we have many independent variables. Age, education, income. See, that one should be multiple.
I think it is Poisson because the dependent variable here is cars and we are counting the number of cars.
That is correct, but now answer me. Why not multiple linear regression? So when answering, you have to tell me, Oscar, but Oscar, we use multiple linear regression when this happens like this, like this, like this. But this is not that case. You have to answer it that way. Ndambuki, are you still there?
Yes, I'm thinking.
Yeah. But I've told you how to answer. I've said that to answer, you tell me, Oscar, you're saying multiple linear regression. We only use multiple linear regression when this and this and this and this happens. But in our case, this is what is happening, so we cannot use it here. That's why we are using this.
Can I try?
Yes, shoot. Your name?
Amos Wanyama.
Uh-huh.
Okay, for multiple, I think it can take even continuous data, but for here we are looking at discrete, that is the number of cars.
What are you saying? I didn't hear you well. Please repeat.
I'm saying
not that you are wrong.
looking at
I'm just saying repeat.
The discrete number of cars, but for multiple, it could take the continuous variables, that is with decimals.
What do you mean by it could?
It only takes continuous variable.
What do you mean by it could?
I withdraw it cool. Actually, it takes continuous variables.
Now, what do you mean by it? Correct, I agree with you, but what do you mean by it? Or maybe my question is not good. Guys, anytime you talk about regression and you don't have the word dependent variable, you don't have the phrase dependent variable inside there, most likely I'll give you a wrong in the exam. Are we clear on this one?
Yes.
Most likely you'll be talking bullshit, I can tell you for sure. I'm saying most likely. The minute you want to talk about regression and you don't put the word dependent variable somewhere, most likely you'll get it wrong. I can tell you for sure. You have to put that word, because by you telling me that because the variable is continuous, there's nothing you're saying there. We use multiple linear regression because the variable is continuous. Which variable? Are we clear on this one?
Yes.
Anytime I ask you which regression model will we use here, and in your explanation you fail to put the phrase dependent variable somewhere, most likely I'll give you a wrong. Mtu asiseme kusema. Parfait.
Ouais.
Comprende?
Ouais, c'est compris, prof.
D'accord?
D'accord.
Okay. You have to say dependent variable somewhere when you're talking about, when you're choosing regression models. Is that okay? So in our case here, why can't we use multiple linear regression? Because for multiple linear regression, the dependent variable, can you see I'm putting dependent variable? I don't just say because the variable is continuous. It's cars, which is continuous. Account. Is that okay? So the model will be cars, follows Poisson distribution first with parameter lambda.